polymers in the concrete? Well, the time when we created this invention or found this out was the development of synthetic polymers. Well, it increased by a lot in the 1970s and the 1940s, sorry, because of the demand. Because it was such a great thing and it was so easy to make. But in the 1950s, the concrete was actually introduced, the polymer concrete, that is. But it was overseen by the Committee 548 of the American Concrete Institute since 1971. After the 1970s, it uses increased because of roads and other things. Well, what is the properties of cement? The binder is more expensive than cement, but it's significantly greater in tensile strength and all the strengths than the Portland concrete that we all knew at that time. Well, we weren't born, but you know what I mean. It's much faster curing, and the durability is quite strong, and it's for more years than the Portland or any other concrete that we knew. It's really good for reinforcements, and it has really good chemical resistance. All in all, it's a really good concrete compared to everything else. For example, it was better towards water and aggressive solutions. It was like capable of being vibrated with cars and things like that, or other things like earthquakes. Instead of cracking instantly, it might have created small cracks, and it was much more being produced much easier. So, what can concrete do for the individual and society? That's kind of easy to know. Concrete, as we all know, is used for mixtures into creating asphalt or other types of roads, which are really good for example, car tires and us walking in general in paths that we couldn't walk before. Yes, you might say that there can be normal roads there or dirt roads, but as we know, asphalt is very good for tires because they're rubber. And concrete creates a lot of jobs because a lot of the houses are made out of concrete, and there's no one creating concrete, then there's less jobs, and there's much harder to create other things. And the chemical usage of concrete doesn't release any radiation, so no one gets sick from the houses and other things as other material could. And it's, as I said, it's really strong, so your house won't just crumble down if it starts raining. But we already know that we can create houses and roads and all things, but what if they break? Are they disposable? Sadly, since concrete is a mixture of cement and other things, it has a lot of carbon dioxide released when created. Not itself, but the cement and other mixtures before it becomes concrete itself. The disposable, you can't dispose it just anywhere, but you can, on the other hand, reuse it for 100% of its material and 100% of its strength from the beginning. So it's not like if concrete breaks, you can take it all, mold it, and put it back where it was, and it will be the exact same like it was before. About how the concrete releases a lot of carbon dioxide to make, but how does that actually affect our environment? It affects it because the carbon dioxide releases. Then it is a greenhouse gas, which keeps more radiation on Earth and heats our oceans up and the Earth up itself. But it can also be infectious in that it can make our waters acidic, it can hurt our lungs, as we can see in parts of China and things like that. There's too much carbon dioxide and you have to wear masks all day. But the concrete itself. The problem is, we already talked about the carbon dioxide and things like that, but whilst it builds up land, it actually takes other down. Because the carbon dioxide that gets released heats up the earth, as we know. And when the icebergs melt, the water rises, and then India and other countries might just submerge. Thus, the concrete has created other land that we can live on and more things, but it also destroys it.
So, there are two different types of polymers in concrete. So there's PCC, which is also known as polymer cement concrete, also called polymer Portland cement concrete, which is also known as polymer modified concrete. The other type is called PIC, polymer impregnated concrete. Now, for you as a viewer, you might not think that there's such a big difference between these two polymers, but they are very different. They're used for different structures and in different ways. A big difference, first of all, is that they do have two monomers. or not two monomers, they have different monomers, sorry. And if we were to take the PCC monomers, they're often polyester styrene, epoxy styrene, or furans. And these monomers are used thus to make polymers through polymerization. And for PIC, the monomers are methyl-methacrylate, which is also used in teeth, which I will talk about later, which is a very interesting fact that our fillings have the same monomers as monomers that are used in producing polymers for concrete, which is a very interesting and important fact. One big difference between PIC and PCC is that PIC has a higher density than PCC, but is essentially dependent upon Portland cement binder for structural integrity. Now I'm talking about the PCC. And PCC is an alkaline material reacting with acids, neutralizing the acid, and while simultaneously destroying the concrete matrix. So that's a very huge difference between these two polymers and these two polymers in concrete. And it is very important to understand the different capabilities of the PIC and the PCC as they relate to acid-proof construction. And if you're interested, or if you study construction, this is a very big and important thing when constructing buildings, houses, schools, and other such things. And the terms are very similar and sometimes used interchangeably, understanding that materials containing the Portland cement binder in PCC are susceptible to acid degradation, and that's a good first step in sorting out the differences between these two. And there are several other differences, and there are several similarities, but these are the most important differences to understand, and thus that is why I'm taking them up. The production of PCC it's made by Portland cement, which is in its name, and aggregates just like ordinary concrete, but organic polymers dispersed in water, and these are added at the time of mixing. The organic polymer is a substance composed of 1,000 simple molecules Now this is important to know. As these are just monomers. And these combine into large molecules through polymerization to get polymers. This is the most important reaction when when making these polymers for concrete, from a monomer to polymers, and this is the sense for every other polymer there is. And another very important fact is by adding polymer dispersions to these concrete mixes, bond strength to these concrete substrates, flexibility, impact resistance, resistance to penetration by water and by other salts are improved. So if we compare two monomers, one in each, in polymer impregnated concrete and in standard Portland concrete, and if we take two monomers and we can talk a bit about them. So if we start off with PIC, so this is a monomer of polystyrene. Oh, sorry, stop it. It can't be a monomer. It's just styrene, and this is its monomer. And with this structure, it is nonpolar, and there is no hydrogen bonding as there's no oxygen, and there's no atom in the structure with a high enough electronegativity. Thus, its real only intermolecular force that it can have is dispersion forces. But it also has covalent bond crosslinks, which is a big thing to think about. However, if this monostyrene was to be a polymer, you would connect it, but you would also call it N. And you'd write this as N, and this is N equals to 1 in a sense. And then for every chain you have, you'd add like 2, so you'd have 2 of these chains. If you had 3, you had 3, 4 and 4, and such and such. Anyway, talking about this monomer, it is very different as it doesn't really have that many forces. Only dispersion, and it has covalent. Now, if we were to talk about PCC, a monomer, there is epoxystyrene. That's another part of the styrene family. However, now I have written a ring structure, and maybe you haven't gone through ring structures yet, but they are very important and they are very vital for chemistry, especially if you want to read on a higher level. Anyway, you can see that there is an oxygen there, and this being its molecular formula. Thus, we can already conclude that there is hydrogen bonding and there is dispersion forces. Hydrogen bonding and dispersion forces. But dispersion forces is kind of a given thing, and nearly all forces have dispersion forces. It's a given thing, not that much to take in. That most structures do have it. Anyway, it does also have a very low boiling point from 197 degrees, thus indicating that it does have a very has pretty weak forces, as that is a very low boiling point when you think about it, as water has a boiling point of 100 degrees, and that's not so far off it, just by 97 degrees. And as I was saying, how PIC contradicts with the thermosetting monomers to the styrene, it's kind of the same here, as hydrogen bonding is a very strong bond, and it's pretty, famous for being very strong, which is kind of interesting to take in when epoxystyrene has such a low boiling point, thus indicating it does have weak forces.
Bones and teeth, also known as the hard part of our body, are partly made of organic compounds and partly made of inorganic compounds. Enamel, which is the outer layer of our tooth, is approximately 92% made of crystallized calcium phosphate. Now, tooth can decay, also known as caries, due to foods such as sugars and milks and all kinds of carbohydrates. You're probably wondering, what does this have to do with polymers? Well, when your tooth does decay, you need a dental filling, and the filling in your tooth can be made of polymers, also known as a composite filling. Composites used for filling teeth are generally made up of silica and glass particles bound with a polymer resin. Now, these also have advantages and disadvantages. Since this technique is newer, it also costs more than just amalgam fillings. But advantages can be that the color and texture are much better than amalgam teeth. You can design the color to fit the patient's tooth. However, disadvantages are that they're less durable and much less dependable than normal amalgam fillings.